Hey, this is a tutorial on how to integrate the SmartLocomotion framework with the Sneaky Kitty Games shooter framework. Just wanted to show how I was able to merge the two together. The SmartLocomotion kind of project slash framework is on the marketplace. You can get it there. It's replicated for multiplayer. It's got parkour stuff, mantling, rolling. It's kind of got a full gamut of mantling, vaulting, rolling, and sliding kind of implemented and fully replicated um, in Blueprint, so it's easy to prototype with. At least in the beginning of your game, you might want to implement some of this stuff in C++ later, but for just quick prototyping, it's a good place to start at least. And so yes, I'm using that with the Sneaky Kitty Games shooter framework, which is an incredible um, multiplayer shooter framework that is fully replicated. Um, get the just show it real quick for anyone that comes across this video. Yep. So Sneaky Kitty Games shooter framework. It's all it's a C++ based project that is like super robust and really modular. So it's really great implementation of a first person, true first person shooter game that has a lot of other really excellent replicated back-end stuff that makes making a truly robust, true first-person shooter game easy to prototype and really probably move forward into production with. It's that level of plugin. So anyway, so that's what I'll be doing in this video, integrating those two things together. So yeah, so let me go ahead and start with that. Um, Okay, so I think probably the best place to start is to look at like ask the question like which one are you integrating into which one. So I'm integrating. So if you go to Sneaky Games GitHub page and you get download their version 2 example project, you'll end up with a project that has this folder in it. And when you create the Smart Locomotion project, you'll have the Smart Locomotion project with this folder in it. I'm migrating the Smart Locomotion into the Sneaky Kitty Games framework. You probably could go the other way as well, but I'm going from here to here and starting with this example project as the example project. And so because I'm doing that, you need to enable some plugins right from the get-go. And if you go to animation and plugins, you'll see the animation locomotion library. You'll see animation warping and also motion warping. Those three are enabled in Smart Locomotion, and they're also enabled in Lyra. Smart Locomotion takes a lot of its techniques and its animation logic and framework from Lyra. It's kind of the new way of doing animation stuff, and Lyra and this framework require those plugins to be installed if you want to work with this. It won't work at all if you don't have those installed. So you need at least these two, if not also motion warping as well, for stride orientation and slope warping and all that stuff. So yeah, so install those. You'll need those. And then maybe the first thing to look at basically would be the kind of unadulterated, unchanged Smart Locomotion Smart Locomotion project's animation blueprint, just to kind of go over like what it's doing, because we're going to be taking the Sneaky Kitty Games animation stuff and integrating it into this. This is a bit more complex because it's so movement oriented, whereas Sneaky Kitty Games framework is designed by from the start to be modular to move into your project. So we're using this animation blueprint as the base, and we're moving Sneaky Kitty Games frameworks procedurals into this kind of base. So let's just go over this real quick. I'll just do it quickly so that you can understand kind of what's happening here. All your main locomotion stuff for the Smart Locomotion is happening in this in this state graph. So you basically can just think of this as basic locomotion kind of area. You'll see that I didn't change any of this. This is a ragdoll state where if you're dead, you're not going to do any of this anyway. So that's all this Boolean is doing. And then here early on in the graph, we're basically splitting upper body and lower body. And we're using a root bone rotate logic here because it's required for the turn in place. You'll see that anywhere you see a tutorial on how to do turn in place, you'll see this rotate root bone logic kind of happening with this root yaw offset. So that's required for the lower body. And then anything else is happening it's going to be applied to the upper body, and then we're blending by bone here. So this is the Smart Locomotion animation blueprint, and the way they're doing this is using a branch filter. The way Sneaky Kitty Games is doing it is using, you'll see this later, is using a blend mask. So you'll see this in both projects, are just doing it differently. This is the aim offset stuff that's being done in Smart Locomotion. It's not very accurate or complex. So this is something we're just going to get rid of because we're going to replace that with a more robust procedural aiming and all the stuff that comes with the Sneaky Kitty Games framework. We're going to get rid of this, but it's here. You can see how it works. And then on the back end, so here's our output pose, right? So this is the last bit of the animation graph. They're doing the orientation warping, foot placement IK stuff, stride warping, leg IK, and this pelvis leaning stuff here. Orientation warping is all about orienting your animations to the direction of movement so that you can just use a forward and backward running animation, walking animation, and the body will rotate to accommodate which direction you're moving so you don't have to do like an 8-way blend space with 8 different animations for diagonal, forward, back, and try to blend between the extremes of those things, which can cause a lot of like foot crossing and leg popping and stuff. So this is one way of kind of getting around that. And you'll see where we have to implement this in the other one soon. And then stride warping is, again, from Lyra's framework, and it changes the stride length for dependent on the speed as well as the speed of the footfall. So it's doing both of those things simultaneously. And it's kind of a procedural way of doing that so that you don't have to have a bunch of different animations, and you can kind of more directly match what speed you're going and what direction you're going. So leg IK stuff here, and then this transform modify bone pelvis in this particular anim blueprint for the Smart Locomotion. This is doing the body lean, but we'll get rid of that because Sneaky Kitty Games framework has a much more kind of modular and more precise leaning logic implemented. So this is just kind of cosmetic in a way. It's not really associated with the precision of the procedurals that we are going to implement for the Sneaky Kitty Games framework. So we'll get rid of this anyways. But we are going to implement this root bone modification that's kind of optional here, and I'll show you. I'll tell you right now actually. So in this logic, we're basically just raising the root bone of the character by 1 unit so that the foot placement stuff, which is always line tracing down to the ground, is always a little bit above the foot, above whatever surface you're on, so that it doesn't, start below that and then pass through and then kind of mess up. So yeah, so this is what this is doing, and we'll implement that just so that we have it in the other graph. Okay, so that's the unchanged Smart Locomotion animation graph. Now let's look at the kind of unchanged Sneaky Kitty Games animation graph. And he covers a lot of this in the tutorials, so you need to look at those tutorials first. If you haven't gone through all of the tutorials that he's put together, then let's go where those are. So here they are. So if you haven't done tutorial 1 through 10, at least tutorial 1 through say 5, and even some of this fixing the character animation stuff, if you haven't done that yet, you should do that. This is kind of a requirement. I'm assuming that you have done all that stuff. So if you haven't done that, you should go back and do all of that first. it's really super comprehensive, and it's kind of required to go forward for any of the stuff for the procedural stuff. You'll need to have the firearm set up. You'll need to have the skeleton set up and all that stuff. So that at least these first four, and but I would just go through all 10. It's quick. You can go through all 10 and get everything set up first. Makes everything much easier, and you'll understand that framework a bit better. But so here's his animation graph, basically unchanged. So this is the animation graph unchanged. We are going to, so this is the locomotion stuff that was happening in the other project animation blueprint, but it's a little bit simpler because this is not designed as a movement plugin. It's designed as, for its powerful procedural, first-person shooter plugin. This is basic locomotion set up here, and then you've got the animation stuff here that's specific to whatever weapon you're going to be using. You'll set up he shows you how to do this in the tutorial, but you'll set up a specific animation for every a weapon you'll be using, and you can tweak that single frame pose, which then gets used by the procedural animation to do things. So you can tweak the fingers and tweak all the kind of hand position and things like that to kind of get it right per weapons. And so yeah, so that's what this is doing here. If we go back to the anim graph, yeah, so that's what's happening here. That's all being modified by this gameplay tag. So you can switch between weapons using this gameplay tag, and we'll use this logic again in our animation graph, or the one that I made. This is the linked anim layer from the Sneaky Kitty procedurals. So just to be clear on this, he covers this in the tutorial, but for every blueprint that you want to link the procedurals into, so your main animation blueprint, you need to make sure you have the interface set up. There's some great tutorials by Stephen Ulibarri on how to do that and like why you do that. So if you don't know about animation layer interfaces and how to do that, look for some tutorials on that. It's kind of the new way to become more modular with your animation graphs. So yeah, so that's what he's doing here, which is great. And so we're able to just bring this into any main animation blueprint we want to, and use it as a kind of to augment what we're doing. And then down here, you'll see the layer blend per bone that we were talking about before. This is using the blend mask instead of the branch filter. So that's how all of the upper body stuff is being blended together with the lower body stuff to create an upper body, lower body split. All of the arm and hand IK stuff that's related to raising the weapon and doing all that stuff is happening down here at the back of the chain. So this is happening after all this stuff, and it's important that it happens after this stuff, and you'll see that in the next animation blueprint. But it's important that it happens here at the end, and we'll just copy that over to the other one. So yeah, so just keep that in mind. I'm not using free look, but I haven't found any problems with just keeping it there, so I just had left that here, and I'll probably implement that a little bit later. Okay, so let me just show you one more change that I've made so that you understand fully like what I've done before we go into the specifics of what I've done. So in this procedural animation graph, just want to point out that right now I'm not implementing the shoulder switching, so there's no switching between shoulders right now. I'm kind of bypassing that because I don't necessarily want that in what I'm doing, and because this is once again so modular and great, you can just kind of pull that out and you don't have to use that part of it. So I'm going from the input pose here to the offhand IK pose directly, and just kind of bypassing this before shoulder and after shoulder, and going straight down here to the offhand IK. So I'm bypassing all this and going right into that. Just wanted to make that clear that I'm not doing this. If you have problems that are created because of this, I won't know exactly what that is. So on the Discord, I wouldn't necessarily be able to help you, but it's there. And I might implement it later or and troubleshoot that later. But for right now, I'm not using that. Okay, so just want to make that clear, like I'm not doing this here. Okay, so now let's jump into the modified anim blueprint that I put together just kind of during the merge and some things I figured out during during the process. And we'll just start from here and just go across to there. So yeah, so this first part of this is unchanged from the Smart Locomotion plugin. There's no changes here. Um, if you see differences in all this stuff, that's because potentially you've done something different, but this is all unchanged from the others. This is the ragdoll. Are we dead? No. Okay, well, if we're not dead, we're going to go through and pass all the way through. Um, so here I start changing things. So this is not changed. So this logic is coming through a cache pose up through here and going into the rotate root bone. But I'm moving the animation warping from where it was up here in the front of the graph. It used to be here. I'm moving it now back to the back for a reason. If this is here, it's going to start warping your orientation across the full body. And it's going to not be able to be split out from your upper body as easily. And that's going to cause jerking and weirdness when you're trying to do aim down sights and when you're trying to kind of move laterally, strafe basically. It's going to cause you problems with that. So I take it out of here. I kept it here just as a placeholder to remind me where it was, but this was here, and I've moved it back here. So it's just after the root bone. It's here, has not been changed. None of this has been changed. I did not change any of this. I just moved it back here. Okay, and so that it can be isolated to the lower body. Root bone is happening for turn in place. This is standard for turn in place. You need to rotate the root bone based on this root yaw offset. Any tutorial you go look at for turn in place is going to have this logic basically in it, and then orientation warping, and then isolation to the lower body. Okay. Now, for the upper body, there's been some changes, right? So this body split cache is being cached here, but it's also now being passed down here. You'll recognize this from the animation blueprint from Sneaky Kitty Games. It's the same thing. It's changing the weapon by gameplay tag. The only difference here that I've done is I've gone in and created a custom pose for my weapon. There's no this is he in this framework, in the Sneaky Kitty Games framework, he's intentionally and in a good way forcing you to start thinking about creating custom animations for every single weapon, which is really what you want in a first-person shooter game. If you've done other things that are more hacky, like just kind of just other techniques where the animation isn't doing the extra work of posing and placing the hands and things, you'll want to break that habit, because in a first-person game, the way your hand is touching the gun is so clear and so apparent. This is what's handling all that. So you definitely want to implement this and learn that workflow of how instead of creating a bunch of different nodes to do hacking together logic, you just duplicate, let's say, this animation and create your own custom animation. It's a single pose, change the bones and key it. He shows you that in his animation, in his tutorial. And then you have one of these for every single weapon that you're using. And then back in the anim graph, he's implemented gameplay tags so that you can switch between these. And of course, you can keep adding more of these as you go. So that's how he's doing the switching here. Okay, so that being said, this is all standard from the Sneaky Kitty Games animation blueprint. And what we want to do next, though, is we want to isolate this stuff, okay, when we're doing away from or stop doing this pose and all of this, when we're doing things like climbing, sliding, climbing ladders. This climbing is the Boolean that's used, and I can show you where that is or where that comes from, but this is the Boolean that's used, and it's being, just to be super clear, because I know this was somebody asked this question in the Discord for the Sneaky Kitty Games Discord, is this is a property access node. So if we go to property access, okay, and this is covered in Stephen Ulibarri's tutorial that I mentioned. I'll post it in the links in this video, but this is a property access node that you can use to get properties from different different components and different parts of the game logic. This is used for thread safe animation stuff. So instead of grabbing variables directly, which could be changing on the fly, the property access is able to grab thread safe, in a thread safe manner for during animations when it's appropriate and when there's a free thread in the game thread. Grab a variable so that we know it hasn't been changed since the last time it's been grabbed. So for instance, this is climbing is coming from the parkour component, I believe, and it's here. And so you can just grab that here, and it's grabbing get component is climbing. That's basically exactly what this is. Implementing thread safe functions is something that Stephen, or in other videos you'll see how to do. Yeah, it's kind of the new way. So it's important to learn it, and it's what Lyra does as well. So anyway, so that's what we're doing here. And so if we're climbing, sliding, or climbing the ladder, we don't want to be doing procedural aiming. I mean, of course, unless you do want to try to integrate those things with some of these things. But for the most part, these are full body, full body things. And so doing procedural aiming during those doesn't really make sense. So we have to kind of isolate this stuff. So that's what this Boolean does. If we're doing those things and those things are true, then we're really just going to bypass any of this procedural logic. We're just going to pass into this cache node, which we'll then use somewhere else. But if you're not climbing, sliding, climbing a ladder, you want to, which is most of the time, so false, you want to pass into the procedurals. So here are the procedurals. I have this linked by anim instance class. I think you can stop doing this at some point, but I'm doing this still because I'm just a little like, I don't want to have any problems. And this is a way of directly referencing this back to the procedural anim layer. So you need this at least in here, and you may want to start with this linked depending on what you're doing. So all of this process from body split basically is coming through here. So basically this is body split cache passing into here, but we needed to cache it to do these Boolean checks. This is passing into the procedurals for the upper body, and then we're having to split it again just based on the logic so that we can isolate this if we need to. So same Boolean checks are happening again here. So they're happening here and here. They're also happening one more place in the anim graph, and I'll show you that. And then we're going into, I'm using a full body slot here. This could be upper body. I haven't seen much of a change there. But yeah, we're going into another slot so we can kind of isolate on the skeleton where all of this stuff is happening. And then we're taking all the lower body stuff and all this upper body stuff and blending it together in this blend per bone using the blend mask that that he sets up in the tutorials. So yeah, you can get kind of both of these things. You can understand this logic and how to set it up in the tutorials that Sneaky Kitty Games dev that I told you about before. So you can do all that stuff and understand why and how he's doing blend masks and how that needs to be set up on the skeleton. He goes over that in the tutorials. Okay, so then because this aiming logic from the original SmartLocomotion, we're not using it anymore. It's not needed anymore. I just keep it here as a placeholder to understand if I need to troubleshoot or whatever. I just keep it there just as a reminder that it was there, but we're basically bypassing it. We're coming into this aim offset, and then this aim offset cache is jumping across to here. So like I said before, we took the orientation warping out of here. Now we're doing all the foot placement stuff and all the stride warping stuff. So this is where used to have, so what was before was this pelvis leaning was here, and the root bone moving was kind of down here, meaning this wasn't being used, this was being used. Well, we don't want the leaning because the leaning is happening in the Sneaky Kitty Games framework's procedurals as an option, and there's C++ code that's doing the work on the back end, or well, his procedural layer is doing the work for this. Actually, sorry, his procedural layer is doing the work for this in combination with the backend code, and but we do want to, kind of move the root up just for safety's sake so that we're just a little bit above the landscape, whatever we're walking on, so that when we do the line trace down, our feet go right down to that rather than starting a little below and then our feet looking for something really far down. So that's what this is doing. So we want to keep that there. And then this is unchanged from the SmartLocomotion as well. And then we're passing into another cache node because we need to do some more kind of splitting up over here. So every time you do that, you need to cache things. So we're caching it there. Okay, so here we're using those same Boolean checks once again in order to, isolate this hand IK stuff. So if you're climbing a ladder or you're sliding or you're, doing all that stuff, and maybe if you're sliding and you still want the hand IK, you might try to use that stuff, but you'll have to figure out your animations for that because you know, this is happening on the upper body, sliding is happening on the whole body, so you may end up having some problems there. But so right now I'm just isolating this. So if I'm sliding, the gun goes away, and you know, uh, is intended to maybe like scale down, like they do in Lyra, scale down that bone to 0. Um, but so for now, just for testing purposes, um, I'm not trying to implement something more complex like that yet. I'm just isolating this so that this can get turned off when these other things are happening. And that's really all this Boolean is doing, and that's why all this caching is happening to having to happen here, is because I want to do um, this Boolean logic of stopping this from happening. Otherwise, this here, okay, all of this is literally copied from the main anim graph in the Sneaky Kitty Games example project. This is just literally copied over um, from here to here, okay? And I took the free look out because I'm not using free look, all right? So that's all happening here. Again, caching to here, and then caching is coming in here to the false. So again, if we're not doing this, which is most of the time, if this is false because we're not climbing, we're not sliding or whatever, then we're using all the procedurals up through here and then coming into the output pose. So that's how this anim BP is combined with the other anim BPs plus the procedural layers. And then I guess maybe one more thing to show really is, you know, maybe if you have problems or something with setting up firing and all that stuff, I can show you how that works. There's been some changes, at least to the in a okay, let me just say this to make it clear. This is the SmartLocomotion's base character. Okay, so that's the SmartLocomotion's base character. Because all of this blueprint logic is much more complex, and so just starting here is probably better, and integrating Sneaky Kitty Games I felt was a better way to do it. Um, since you're implementing the component shooter game, the shooter pawn here, so giving it all that stuff, you can bring a lot of the functionality into this through this component. Once again, because Sneaky Kitty Games is like, they're both componentized, but Sneaky Kitty Games components, are just kind of more like there's less interfaces, there's more backend C++ code that's doing a lot of the work for you. So this one's a little bit more easily integrated into other projects. Okay, so anyways, my point is that I've done some things in Begin Play from moving the input mapping context to the player controller and such like that. But the main thing I wanted to show you just to get this kind of smooth and working smoothly is if you look at like I've basically going into edit camera. Um, I've all the free look stuff I took out of here. If I want that, I'll use Sneaky Kitty Games framework for that. So anything related to free look, I've taken out. Um, uh, Default camera limit angle, not haven't found that to be an issue. Haven't disabled that. But in the Smart Locomotion plugin, the way that framework is just getting kind of what seems to be natural movement of the camera while you're walking or while you're standing, kind of almost what you would consider like a sway, and that's kind of generally happening here. And then after you jump, even more shake. That stuff is implemented here, but because we're using the procedural aiming and swaying, you kind of want to, I think you probably want to want to dislocate that stuff. So you don't want any shaking or jump shaking. I found that to be a problem during implementation. This started to kind of go crazy and go haywire, and the shaking never stopped. So I said, well, I don't really need that. So it's cosmetic anyway. So, and we're doing that procedurally now. So all that stuff I kind of disabled in the camera stuff. And yeah, so that's kind of the main things that I changed to get this all to work. Maybe I should have done this in the beginning of the project, but let me go ahead and just, some people have seen this on the Discord for Sneaky Kitty Games, but just to show you kind of what this looks like, it's again because we're using two of these frameworks that are both replicated, you've got full procedural aiming with all the incredible sway and procedural stuff that's happening per weapon that you can customize in Sneaky Kitty Games framework. So movement sway and all the sway stuff is happening on the upper body. And then if we look down, you can see the lower body is still doing the turn in place animations. It's a first person, framework. So, we're true first person, that is. So we're seeing all the lower bodies having to do like two different meshes or whatever. And, all this stuff is working. And then if I switch over, let me pull this guy back a little bit so he can be a spectator, and then kind of come up here and start playing on the client. You can see the client is working, and in the server's frame, you can see that the client is fully replicated to the server, and all the animations because of the smart locomotion are replicated. So like rolling is implemented, fully replicated. Vaulting is fully replicated. None of this stuff has been tuned yet, but it's there, and you can climb ladders and all that stuff. Eventually, probably I will just scale the weapon down using a scale curve in the animation montage to kind of handle the weapon just kind of going away while you're doing that stuff. They do that in Lyra as well. So anyways, you can see the kind of how this ends up being. This isn't done yet, so there's still some issues and things to iron out that I haven't ironed out yet, but I don't see any huge roadblocks to using these, at least to prototype. So anyways, that's how I was able to kind of implement both. And on the Sneaky Kitty Games shooter framework Discord, I'm willing to answer questions about it some more if you have some problems. But I'm not an expert, and this is just what I've done to get it to work. So if your questions start to become super like, oh, I did this custom thing and I did this other custom thing, I mean, I can try to help, but really the way I solved this problem was just through lots of print strings and lots of just trial and error. So, that's part of any game development process. So anyways, just thought I'd give you a heads up on how I did that, and yeah, see you in the Discord. Okay.